Hello everyone, Leonard here. I'll start by telling you that this type of videos is simply meant to help me keep a record of different projects I've been working on and also speed up future recruitment processes by sparing you the time you'd have to invest in downloading the project and setting it up on your local machine. This specific video is about aMAZEing, a team project developed in college for Introduction to .NET course. As a brief summary, just for you to know what to expect from this video, I will give you some context, what this project is about and why I think it is a great one. I also plan to cover our choices in terms of development approaches, tool stack, and also ways of making this project public on the web. The final section of this video will be dedicated to a short demo in order to point you out the main features of our app. But enough with this intro, let's get into it. Okay, so this project idea came after watching Clement Mihailescu's video that I'll link in the description, where he presented many different projects he worked on over time and helped him get a job at companies like Google. Considering my competitive programming background, one specific idea stood out for me. It was basically a web visualizer for pathfinding algorithms. I really wanted to do something similar one day, and that day came. After several weeks of learning the basics of .NET Core, we had to team up, come with a project idea and implement it in 7 weeks. We took advantage of the context and chose this idea because it is as much user-oriented as it is developer-oriented. When it comes to the end user, this project is very visual and easy to use, and it has educative purposes. And for the developer, this type of project is really challenging to develop. It offers a great learning experience and it represents a good practice for code interviews. All in all, it is a project nice to have in your portfolio because it showcases many different skills. Now, coming back to my story, time was short, so we started debating about the business model because we thought the original idea lacks the human interaction component. After that, we used Figma to create the mockups for our app. The design had to be modern and intuitive, and I think we accomplished just that. Let me show you. So this is our Figma project. As you can see, it is really simplistic with vivid colors and quick action buttons that redirect you from dashboard to leaderboards or to the build maze area or to the solve maze area. Also, our dashboard is separated in many different sections, one dedicated for stats, one dedicated for mazes that you have created, one dedicated for mazes created by the community or the playground, the way we like to call it. And on top of that, we got animations in place that I'll show you on the demo that are meant to show effectively how those pathfinding algorithms work in finding the optimal solution. For our development approach, we had to take into consideration that besides time spent in classes, one member of our team is also a freelancer, and I was caught with the job, so meeting all together was never an option. We concluded that definition-driven development would be the best approach. So we started defining our models and endpoints that threw not implemented exception at the time. But this way, we could share a Postman documentation really fast with sample requests, as you can see, with different endpoints exposed by our API. This way, ensuring that all of us are on the same page. It proved to be really helpful in aligning the front-end Redux store with the backend models, and also really important to us in decoupling our work. To reinforce this idea of decoupled work. We also set up a GitHub repository that you can see here with commits from the contributors with different branches for master, backend, or frontend. I will also link this down below in case you want to check it out. Moreover, there were things not so clear at that time, so we wanted to be as flexible as possible with data retrieved by our backend. And we managed that by designing DTOs that were implementing builder design pattern. All these little things helped us a lot in delivering everything in time. Now, some words about the architecture and tool stack we chose for the app. Microservices seemed a bit over-engineering to us, so we went for a classical monolith with a layered architecture and a security component. The backend stack was based on .NET Core, Entity Framework, and Microsoft SQL Server, while the frontend was developed using React, Redux, and Redux Saga. After integrating all our work, we wanted to go online, and in order to do that, we made use of cloud services like Azure and Netlify to do just that. Here you can see our Azure dashboard with poor activity because I was the only person playing with the platform today. Okay, and now the moment you came here for the demo, let's get into it. So this is the welcome screen, our login page. Let me insert my credentials. Apparently I've misspelled it, let me check. Now it should be fine. Yes, it is. And here we are on the dashboard. You can see all those sections I've told you before. Here you can see the statistics, mazes that I have created, and the playground with mazes that I have solved and mazes that are available for me to solve. Let's check a solved one. Blaze it, for example. Here we can see the solution that I have submitted for this maze and my accuracy for this particular maze. One aspect of our business logic is that if I try to play a maze and I view the solution before submitting any, my score will be 0. This is the case for, I'm looking for the D, here it is. I just wanted to show this cute drawing of a colleague of mine. So my score is 0, I can't submit any solution because I have already viewed the solution. Let's view it again. Maybe try bidirectional, breadth first search, and see how it works. Apparently it's checked almost all the available squares. Let's go back to the dashboard and try creating a new maze. And we'll do that by placing a start block. We can't place many, but we can replace it. Let's leave it here, for example, and place an end block and some walls. For the sake of the demo, I'll try to publish an invalid maze and see what happens. Apparently our validations caught this no solution found, and I was not able to publish it to the community. I'll try to adapt it a bit, maybe move it this way, and try to publish it now with correct maze. Let's save it. Okay, it should be public now. Okay, it is the first one. We can try to view the solution, maybe try with bidirectional. Okay, and it found the optimal solution. Let's go back to the dashboard and try see other mazes, maybe the maze. I'm looking for the maze. Okay, here it is. And try running A-star algorithm, which should check really few squares, but due to its heuristic, it won't find the optimal path. Here you can see this path is clearly not optimal, and try to run it again with an algorithm, let's say breadth first search. It definitely checks many squares, but it should find the optimal path, which should go this way, and it does. Let's try to create a new account. Let's call it demo user. Here we are. We should be in the last position in the leaderboard, and here we are. Let's try to improve this score by solving the correct maze. Let's try to do it perfectly. Okay, we got 100. Let's see the leaderboard now, and we are in the first place. Well, this was pretty much what I wanted to cover in this video, so if you reached this point, thank you for attention, and if you want to give any feedback, feel free to do just so in the comment section below. See ya!